All right, are we recording now, Stephen?
Yes, we are.
All right, so tonight, take-home quiz. Okay. And I still have the take-home quiz. How awkward is that? I just get so wrapped up in other activities that happened this morning. So fun. Everybody in the office is like, what are you going to do on your birthday? I was like, well, I'm going to teach Calc EC, and I'm going to teach Calc AB with Mr. Lynn, and I'm going to teach AQR, and I'm going to drive to Northside, and I'm going to write an exam. How else would you spend your birthday? You and that. And you know, enjoying some tasty treats from Shipley Donuts. All right. So let's take a look at the homework that you guys are working on tonight. This is the take-home quiz. It's 6 multiple choice questions. 6 multiple choice questions. You have a total of 24 minutes. I have a feeling that's going to be more time than what you need, but when I wrote this quiz, I also knew that the AB students were going to be taking it, so if it's more time than you need, great. Enjoy the fact that it's more time than what you need. Then there is 1 free response question on the back. You get a total of 6 minutes. You get to use your calculator actually on the entire test. Honestly, I don't think you're going to need your calculator. However, some of the problems you're going to wind up doing some stuff with the numbers, like you're going to have to like figure out like 9 squared or whatever, and I didn't want the computation side of things to be what gets in your way. Pretty good? Okay, so you're going to get this done. You're going to get it turned into me tomorrow. It is going to be a very good experience. Tomorrow is a review day, so that you guys are ready for the take-home test that you're going to get on Friday. That'll be due on Monday. And Monday, there will be no homework so that you can all go trick-or-treating. Not at my house, but thank you anyway. All right, so there's that. If you guys can take out the homework on implicit differentiation that I should have picked up yesterday, but it was a short day and we decided not to do that. I think when I gave you guys the assignment, the expectation was you would do 10 of the questions, and I said if you did all 15, I forget what page it is as well. 15, 17, okay. So anyway, 10 multiple choice questions. If you did all 15, this is just like extra love and kindness, and you're lower. I'm going to find a low homework assignment grade and boost it a little bit. All right. So number 1 is C, number 2 is K, 3 is K, and 4 is D. How do we do on this first set? Everybody mostly okay? Right, I think one of the things that I like about implicit differentiation is you're just practicing your derivative skills. You've got this new rule that when you take the derivative with respect of a y term, you multiply by the dy dx, and everything turns out well. Number 5 should be K, 6D, 7B, and I believe 8 is F. 6D. Is everybody still doing okay? 7 was B. 7 was B. I realize you guys are like juggling your priorities. Celeste is like, I have my kolache and I'm supposed to be checking the homework. I can't do both, so let me just eat. All right, number 9 is E. 10 is D. 11, D, that one's a little nasty. 12 is B. 13, B. 14, E. And 15, D. So if you could, I am going to pick this up, if you could please count up how many did you get right and put that over the number that you did. I need to know, is it out of 10 or is it out of 15?
Oh, I just started with 18.
Right, so if you could just give me a count on the front, put your name on it, how many right out of 10 or out of 15?
I did 11 probably.
You did 11 or out of 11. Okay. How many of you guys got at least 8 of the ones that you did right? At least 8. We get 1, we get 2, we get 3, we get 4, we get 5. Number 13 was B. Right, if you did 10 and you got 7 right, 8 right, 9 right, I'd say you're in a good place. Okay, I wouldn't worry if it's, what? 7, okay, I can deal with 7. I can do it 7. Okay.
I don't know. What's what?
What was 12? What was...
These aren't my questions.
I know. Okay, 12 is B.
I did 11 questions.
Alright, everybody good?
7 was me.
Do I want... Yeah, just put your name on it, leave it on my desk. Alright, everybody good?
Yes.
Alright, so if you guys don't mind, I don't want to spend any time going over these problems because I think for the most part we've got this under control. Implicit differentiation is on tonight's take-home quiz. It will be on the take-home test, and I think these are going to be the ones that are like good for you. I want to make sure that we spend as much time as we can in the world of related rates. So while I take, yeah, just leave it there. While I take attendance, I'm just going to put my solutions up here so you guys can check your work against mine. Here it comes. Alright, let me go take a minute. I got a power.
What?
It works out right.
Oh wait, let me look at my multiple choice. Can I see it?
Alright, let me pick up homework over here. That's right, I guess. As long as your name's on the top one. Alright. Jay's friends over here. Thank you. Andrew, thank you very much. Okay, so that's Carmen. We got Lewis. We got Andrew. And we got Steven. Alright. Alright, on the first 5, does anybody need anything read or explained? We're doing okay? So 2a times dA dt plus 2b dv dt plus 2c dc dt. Area of a circle. Now you could use product rule if you need to, and a lot of students will like start doing that. But honestly, it's kind of overkill, right? Pi is a constant. So treat it like a constant. The derivative of pi r squared, dA dt, is going to be pi times 2r dr dt. No need to simplify. Area of a rectangle, length times width. Shame on you if you didn't use product rule. You have to use product rule. All the derivative rules that we studied last unit are going to apply again. Derivative of the first, dl dt times w, plus the first times the derivative of the second, L times dw dt. Now, the fourth one has to be 1/2 dB dt times h.
So it's 1/2 product rule.
So what?
Is it 1/2 product rule?
It's 1/2, and then this is product rule. But for some reason, I put dh dt is equal to 0. Why? Why on this one? What did I tell you in this problem that would tell me that dh dt has to be 0? Lewis, why does dh dt have to be 0?
The height's a constant.
The height's constant. So whatever is happening with this triangle, the base can change, but we have fixed that height, and if the height is a constant, then when you take the derivative, it's going to be 0. Okay, volume of a sphere, 4/3 pi times derivative of r cubed, 3r squared dr dt. No need to simplify unless you want to. If I'm going to find volume of a rectangle, and not really rectangle, this should be a rectangular prism would be the right word for me to put here. Length times width times height. This is where you're going to need that extended product rule that we had talked about, like one time. Derivative of the first, leave the next two alone. Plus the first times the derivative of the second, and then leave the third alone. Plus the first times the second derivative of the third. Is everybody doing mostly okay with these? Good. Alright, volume of a cylinder where the height is equal to twice the radius. Now, this is actually going to be important, and this is not an accidental placement of a problem. The volume of a cylinder is pi r squared h. I'm curious, how many of you guys just you used pi r squared h and you took the derivative and you did the things? How many of you guys use this h equals 2r to make your life a
Oh,
little
yeah.
bit easier? Right, because the height is twice the radius, rather than using pi times r squared times h, I'm going to say pi r squared times 2r. So the volume formula is 2 pi r cubed, and my derivative is 6 pi r squared dr dt.
Okay, correct.
Okay? All right, volume of a cone is 1/3 pi r squared h. I'm not going to ask that you memorize the volume of a cone. College Board is likely going to give it to you in the problem. The 1/3 and the pi are constants times product rule, all the other stuff. 2r dr dt times h plus r squared dh dt. Then multiply that 1/3 pi through. Volume of the cone where the height's always equal to twice the radius, just like we did with the cylinder. Plug it in, you get 2/3 pi r cubed, your derivative 2 pi r squared dr dt. And then this last one, I'm getting a little nasty. Must be what's happened in my old age here. If tangent of theta is equal to x over y, I'm taking the derivative of tangent of theta, derivative of tangent, secant squared theta. And you multiply by d theta dt because the angle is changing with respect to time. And then on the right side, quotient rule. Y dx dt minus x dy dt over y squared. Is everybody feeling good? We got these under control? Okay, I don't want to pick this one up because tonight, and like with the problems that we're going to work on in class today, I want you to have access to this. Everybody's good? All right, back to the world of some word problems. All right, so in your handout, please, if you could go to page 47, and I want you to find one person, or so that no one has to like take on the camera, okay? You can work with 2 people if you want to. If you look on page 47, there is an application problem that is kind of like what we did yesterday with the ladder, but a little bit different. You need to figure out why it's different and where it's different. I'm really interested in what you guys can do with part A and part B. The thing to remember with related rates, you have to find the relationship that's true. Right? We called this the constraint yesterday. There's something that's going to be true. Once you've got that true statement, that's the thing you can take the derivative of with respect to time. Everybody good? All right, see what you can do. I'm going to go have a kolache.
What?
Let's go.
What?
No, no. I got you a card. My fingers are done. I'm awake. Oh, man.
Get married. Hey, can you get married too? I mean,
Airplane flying at altitude 6 miles above the ground, flight path takes it directly over to the radar tracking station. S represents the straight line distance.
it's kind of busy.
The distance between the airplane and the radar tower is 10 miles. The distance is decreasing at a rate of 400. When the distance between the airplane and the radar tower is 10 miles, the distance is decreasing at a rate. So I'm curious, what's the true statement here? What's the thing that is always going to be true that you're going to be able to take the derivative of? Like, that's the thing that you need to find right away. I got Celeste, I got Lewis. What has to be true? The diagram should be a giveaway. That's something that has to be true here. David, what do you got for me that has to be true?
S squared plus x squared equals 6.
S squared plus...
No,
No, the other way.
Careful, careful.
6 squared plus.
Oh.
Pythagorean theorem, like if this
Oh, yeah.
is your right triangle, right, then it's the hypotenuse. You want to
Wait.
Well, wait.
S is the hypotenuse.
S is the hypotenuse?
And X is.
Okay, sorry, and X, it's really hard to see up here,
So
especially as you're getting older. Okay, so x squared plus 6 squared equals s squared is the thing that's true all the time. First point awarded there. Now that you've got something that's true all the time, hey, good news, go take the derivative. Right, and for those of you that are doing fine, just keep going. So 2x dx dt, derivative of 6 squared, 0. 2s ds dt. Getting that derivative right, another point, for sure. Okay, now we've got to be careful and we've got to put all the stuff in that they gave us. The distance between the airplane and the radar tower is 10 miles. S or X? The distance between the airplane and the radar tower, right? We're talking about the hypotenuse here, so that means that S is going to be 10. So when that's true, the distance is decreasing at a rate of 400 miles per hour. So ds dt, 400 miles per hour. I like it, I don't love it. There's something wrong. It's a little bit wrong, but it's wrong. Why negative? Why negative, Aaron? Right, if that distance is decreasing, then my rate has to indicate a decreasing kind of thing. So when that's true, using this information, determine the rate at which the horizontal distance, that's going to be our, what, dx dt?
Yes.
Alright, so what do I need? I need 2 times x. Bummer, they didn't give me x.
You have to plug in
It's
S
8.
into.
Right, and that's like, you're going to go back. Like, once you find that thing that's always true, if this is always true, keep coming back to this equation. Use this equation again and again. And you're right, it's going to be 8. Maybe it's one of those Pythagorean triples that you remember. X squared plus 6 squared equals 10 squared, or you're just gifted with quick calculations. X squared is equal to 64, x is equal to 8. I'm not even going to worry about the negative because we're talking about distances. So 2 times 8 times dx dt equals 2 times s times ds dt. We've got negative 400. And so dx dt, negative 400, negative 4,000, was that negative 8,000? Over 16, I think, is negative 500. Is everybody okay with like the derivative and the process, and we've got this under control? Feels comfortable? Okay, take a minute, write the sentence. What does this mean? Give me that most complete, most accurate sentence. A good explanation sentence. You're going to tell me when is this rate true. You're going to explain the rate in the context of the problem, and you have to get the right units. You need to. I'm looking for all 3. So hopefully sentence sounds something like when S equals 10 miles, or when the plane is 10 miles away from the radar tower, what's happening? When S equals 10 miles, when the airplane is 10 miles away from the radar tower, Paloma, what's happening?
The ground speed of the plane is decreasing at a rate of negative 500 miles.
The ground speed is decreasing
I said negative.
at a rate of, what'd you say? At a rate, wait, Paloma, the ground speed is decreasing at a rate of
500 miles per hour.
500 miles per hour. How are we feeling about that answer? Everybody likes it? Am I the only one in the room that sees what's wrong with this? I'm actually the only one in the room that sees what's wrong with this. Okay, look at it, have a conversation with somebody near you. What's wrong?
Is it miles per hour per hour?
There's something fundamentally wrong here.
You might be right.
Isn't it
You might be right.
is it miles per hour or per hour?
Well,
It's not
that's
ground
what you
speed.
see.
Mm-mm.
It's not ground speed.
I'll tell you, your units are fine.
Yeah.
Your units are
It's not
fine.
ground speed.
And the units should make sense because we're talking about dx dt. What's x? X is the horizontal distance. We're going to measure that in miles. The t is in time. We're going to measure that in hours. There's no problem with your units. The problem happens in the middle of the problem. What you're telling me is that when s equals 10 miles, the ground speed, how fast the plane is moving, is decreasing. That's not what's happening in this problem. X doesn't represent your ground speed, X represents
Distance.
the distance. So what I would have to say is not ground speed, I would say it's the horizontal distance. The horizontal distance from the radar tower. Okay, so when s equals 10 miles, the horizontal distance from the radar tower, that's what's decreasing at a rate of 500 miles per hour. Is everybody okay with that? The explanation is super important. Palomon?
But in the problem, it literally tells the horizontal distance between the plane and the radar
Yep.
is changing. This is also known as the ground speed.
Okay, if you want to, so,
That's why I said-
which the horizontal distance between, okay, but here's the thing then, if you're going to refer to ground speed, your ground speed isn't decreasing.
Your ground speed's increasing.
Your ground speed is how fast are you moving, how fast are you getting closer. So then the mistake would be like, keep ground speed, but don't tell me ground speed is decreasing. You're going to say the ground speed is 500 miles per hour. Right, so your mistake was to use ground speed and then say ground speed was decreasing.
Would it be wrong if we said the ground speed is 500 miles per hour?
The ground speed is 500 miles per hour, and I'd want to say something like in the direction of the radar tower.
Okay.
Because your ground speed could be get closer, or the ground speed could be move further away. Okay, here's the only thing I'm really interested in part B. Can you figure out what's the relationship that's true?
This is part B.
Part B.
This is number B. About 6. Very good.
You know, okay.
Curious, angle of elevation is probably not a conversation we've had since geometry. What does that mean? Angle of elevation, just like put it in your own words. What does angle of elevation mean? Andrew, what are your thoughts? Angle of elevation, what would that mean?
This is
It means theta, sure, but like in the context of this problem, I've got the observer, and the observer's over here, right? It's the angle of elevation.
Yeah.
the angle of the radio tower.
It's the angle like that I like look up to the airplane, right? And I say like from the horizontal, what's that angle? So it's this guy here that represents theta. We've got all the usual players. We've got 6 miles, I forget, was this S or X?
Yes.
S, and so like this guy over here has to be X.
Yep.
If I want to know, and they're asking how is the angle of elevation changing, I need a relationship that's always true that involves an angle now. Something that's always going to be true that involves this angle. One person? Good news, you actually have 3 different options here. You just need something that's always true. Celeste, give me something that's always true.
Sine theta equals 6 over x.
The sine of theta equals 6 over s. Is that always true?
Yeah.
Right? The way that I find the sine of the angle, opposite over hypotenuse, 6 over s. I love it. Another option that you could go with, Aaron?
Cosine theta equals x over s.
Cosine of theta is equal to x over s. And one more that you could go with? Eilay, what's this last one that you could go with?
Tangent of theta equals 6 over x.
Okay, tangent of theta equals opposite over adjacent, so 6 over x. Yeah, you're right. Okay, and if you're really crazy and you wanted to try like a secant relationship or a cosecant or a cotangent, great, but oh my god, what teenager actually thinks that way? If you can go with sine, cosine, or tangent, go with that. Now, are all 3 of them true?
Yes.
Are all 3 of them always true? Then you get to use the derivative of whichever one you want. There's probably one that you wouldn't pick. At least one. Lewis, why wouldn't you pick tangent?
Because like, I mean, you know the everybody like.
We know how to find the derivative, but to take the derivative of tangent theta, now I'm going to work with secant squared theta. God, why would you do that to yourself? It's okay, but probably not the obvious one. There's probably at least one more that you'd get off the list.
I wouldn't.
Which one are you not going to go with?
I wouldn't do cos.
Why are you not going to do
Because you
cosine?
get in with a negative. Well, negative.
Oh,
sine.
because derivative of cosine is negative sine
Yeah, 'cause,
theta?
like if you do sine, you just switch to cos.
You get a positive. Okay, so I think that's a reason. I think there's another reason why maybe you don't want to use this one. What's the other
Yeah,
reason?
it's too rare.
You got 2 variables. You're going to have to do the quotient rule regardless, but oh my god, how ugly is this one?
I don't like it.
And we go from here.
He's low and positive.
Is everybody feeling good from here? All right, time for the push. Here comes the push. All right. I want you guys to take a minute. You're going to go 2 minutes completely on your own. No help from anybody at all for the next 2 minutes. I'm curious to see what your setup looks like. I'm curious to see what your instincts are telling you to do. Everyone's going solo, so it's going to be a nice 2 minutes of silence on my birthday. Remember, you've got to find the thing, find that relationship that is always true in this problem. Alright, water is flowing into a cone at a rate of 2 cubic centimeters per minute. If the height of the cone is 16 centimeters and the radius of the cone is 4 centimeters, how fast is the water level rising? What's the thing that's always true here? Les, what's the thing? There has to be an equation that we're going to use here that's going to pull everything together. We've got the radius of the cone, we've got the height of the cone. I saw it in a whole lot of papers in the back, I saw it in some papers up front. It's that initial volume equation, like that volume is going to be always true, so I can say that my volume is equal to 1/3 pi r squared times h. Okay? So water is flowing into a cone at a rate of 2 cubic centimeters per minute. What the heck is that?
That's the cone.
It's the cone, but what about the cone, Palimon?
How full is getting?
It's how full it's getting, but I need some notation for this. This is telling you how the height changes, the radius changes.
Oh, DVDT.
This first sentence here is dV dt. So dV dt has to be equal to, what is it, 2 cubic centimeters per minute? Positive or negative?
Positive.
Positive, because we're putting water into this cone. We're filling the cone up. All right. So let's see. If the height of the cone is 16 centimeters and the radius of the cone is 4 centimeters, now here we're talking about the cone. We're not talking about the water in the cone. We're saying there's the height, there's the radius. All right. We've got that. How fast is the water level rising? How fast is the water level rising is another like change statement here. How fast is what changing?
Oh, height.
dH dt, dr dt? This has to be dH dt, the water level, like we're pouring water into the cone and the cone's going to fill up. So to help you guys get the visual on that, Palimon, do you mind heading back to the computer for a second? So dH dt equals, we don't really know what's going on. All right, here it comes, here it comes, or maybe not because I forgot to plug it in.
I should have.
All right, and we're not coming because I wasn't thinking, I got distracted by kolaches. I'm always willing to be distracted by kolaches. Feel free to distract me every Thursday with kolaches if you wanted. All right, Palimon. So we've got our cone, we've got the height, we've got the radius. Click fill. And pay attention to what's happening. What I love about this animation is it is true. It is accurate in terms of what's happening in the situation. You're putting in water at a constant rate of 2 cubic centimeters per minute. Okay, here we go. Getting really boring. Getting towards the top. Don't stop. Don't stop. And it moves so fast in the beginning, and then it slows down. Why? Why, Stephen? Why? What's happening? Why is it going so slow here?
There's more surface to cover.
You've got more, right? The water has to spread out more, and here it comes. Right, you're pouring in 2 cubic centimeters per minute, and it fills up the bottom part really quickly because you're only getting 2 cubic centimeters every minute, and that volume fills up really quickly, and then it slows down as you get closer to the top. Does like the situation make sense? Okay. dH dt, is it going to be positive or negative?
Positive.
Has to be positive. The units are going to have to be, we know that this is going to be some positive number. dH dt, how do I measure height? How do I measure time? This should be centimeters per minute. Okay? Now, Palimon, if you can show dH dt, this is going to give us the graph of dH dt. And look at what's happening. Like in the beginning, the height is, because this is the derivative, the height is changing really quickly. Right? Because you're pouring that water in and it goes up really quickly, and then it starts to slow down, like asymptotically slow down. As that mouth gets wider, it's going to take longer for the height to increase. Is the situation making sense for all the friends? Okay, we're good. So there's something else that's always true. I wonder if anybody sees it. There's something happening. This guy here is always true, right? We're always filling a cone. I think this is the obvious thing that's always true. There's another thing that's always true.
Oh.
Don't talk to me, talk to the folks around you. There's
There's
something else that's always true that's going to make your life better.
Little volume, or the volume of the water that's already in.
It's not what's not hurt.
Pi
Should know what's talking about.
RT.
Anything else that's with look at the way that phone's getting filled out. Look at this height, look at the radius. This triangle here is really important. The triangle.
What triangle?
I know I've heard it from that group, and I think this group decided, like, they figured out what was going on and then took a donut break. There is a relationship, if you're paying attention to how this thing is filling, the height and the radius, there's a proportional relationship happening here. Right? You've got this like triangle on the inside that is just growing. That angle stays the same the whole time. This angle stays the same the whole time. That angle stays the same the whole time. What you're getting as the height increases and the radius gets bigger, you're getting similar triangles. And so the idea is this. Palomon, if you could hit stop for a second. So if this guy here represents R as like a function of time, and this guy here represents H as a function of time, there's a bigger triangle inside here to think about, which is like the triangle for the cup. What's in blue right now is the height of the water. The R is the radius of the water. The height for the big triangle is 16. The radius for the big triangle is 4. The proportional relationship that exists between the height and the radius, the height 16, the radius is 4.
Oh.
This guy over here is the height for the water level, that's the radius for the water level. One thing you could do is you could think of it as like a proportion and say that if I compare the radius to the height for the water, that has to be equal to the radius to the height for the cone. So on this side, it's like for the water. For this guy here, it's the full cone. Why this is helpful is if you cross multiply, you're going to get 16 times R equals 4 times the height. Or said another way, your height is 4 times the radius. When's the height 4 times the radius? All the time? Sometimes? At one special moment in time? All the time. If this is always true, and I really want to like hammer this point home, if this is always true, there's a way to use this to your advantage. How can we use this to our advantage? Just make life better. I see one person sees it. What could you do that would make your derivative life so much better?
Oh.
Lewis sees it, David sees it, Celeste sees it, Carmen, what do you see?
You could plug in the gauge into the volume coordinate.
Right. If the height is equal to 4 times the radius, wouldn't that make your life here so much better?
Yeah.
Right? Because without that relationship, product rule,
Yeah.
with this relationship, you're going to say, oh, the volume then is 1/3 pi r squared times, what is that, 4r? And you might still say, oh no, I still need a product rule. No, you don't. Polymon, I think you're good over there. So if you want to come on back, I'd appreciate it. We've got 4/3 pi r cubed. If you didn't see this relationship, all 11 of you, I'm sure, could find the derivative. But this makes life so much better. See what you can do from here. See if you can get the problem all the way across the finish line.
Don't we already know? Wait. Is he in the height?
What do we get for the derivative?
Is it in the height or the volume?
Alright, dv dt, 4/3 of higher constants, derivative of r cubed, 3r squared, dr dt. So dv dt, if I simplify this, 4 pi r squared dr dt. I think some of these values we know, and some of them we need. Which ones do we know?
dv over dt.
We know dv dt, they gave that to us earlier, that was 2. 4 and pi, those are constants. Do we know the radius? Here's where you're going to be careful. 4 represents the radius for the cone. We're talking about like the water level as the water's pouring in.
So we know we have 5 centimeters of water.
So the radius is 5 centimeters?
No. We know we have 5
Oh, so
centimeters. So we can plug
You
it
have
in.
5 centimeters of water in the
We
tank,
can plug it in.
which means you get to come back to this relationship. This is the first time where we've had like 2 constraints that we're playing around with. You've got your volume equation, and don't forget about this one. If the height is always 4 times the radius, what were we told? 5 centimeters of water?
Yes.
Yeah.
So if h is equal to 5 centimeters, then I'm going to say 4 times the radius is 5. So the radius is what, 5/4?
Yes.
Okay. So we've got 2 equals 4 times pi times, what is that, 5/4 squared dr dt. Great, I can solve this for dr dt. 5/4 squared is 25/16 times 4 pi, I think is going to be 25 pi over 4 dr dt. To get dr dt by itself, we're going to divide both sides by 25 pi over 4. 2 divided by 25 pi over 4, a little keep it, change it, flip it. So dr dt is equal to 8 over 25 pi. Pay attention to the units. Radius, centimeters, time, seconds. And for those of you that are like, good coach, I got it, I'm done. You're wrong. Is everybody okay getting to the 8 over 25 pi? Then why is the answer wrong?
Minutes.
Is it minutes? Okay, well that's definitely wrong, yeah. There's something more important that's wrong. Go back and read the question one more time. Read that question one more time. What's wrong here? Lewis, do you see it? What's wrong?
Isn't it, that's radius and supposed to be, I think, for speed.
What we just figured out is dr dt. This is how the radius is changing over time. What am I really asking for? dh dt. Well, how the heck am I going to get dh dt if I have dr dt? Math, yes, good, calculus. dr dt is what I have. I need dh dt. Anybody know a relationship between dr dt and dh dt? Or able to find one? Celeste, what do you see?
You take the derivative of 4r equals 8.
Is it okay to take the derivative over here?
Yes.
Because
It's constant.
no, I want to be careful. Don't use the word constant. Right? Constant makes me think like 14 is a constant. This is always true. Relationships that are always true, you can find the derivative of. So you can take the derivative over here, and the derivative is actually not too bad. 4 times dr dt is equal to dh dt. So taking that derivative, we're going to say 4 times dr dt is the dh dt that I'm after. And so if we do that, then dh dt that 4 times 8 over 25 pi. And of course the units are going to be centimeters per minute. My explanation would be when the height of the water is, was it 5 centimeters? The depth of the water is increasing at a rate of, I guess, 32 over 25 pi centimeters per minute. Make sure you've got that all copied down. Make sure that's all going through. Yep. Okay, so for those of you that are feeling comfortable with this one, I want you to move on to the lamppost question, which is on the next page. If any of the 11 of you are uncomfortable with something that happened here, now would be a great time to ask. I'll tell you, this cone problem is an important question when it comes to related rates. So if there's any part of this that didn't make sense, now would be the good time to talk to me. Everybody's okay? You guys are okay, sorry? Okay. All right, see what you can do with this lamppost. David, do you have a question? No. Okay.
How would you label this kind of thing? How were you just with the shadow moving? Okay, well, where's the sun? It's called the light. Oh, snap.
Okay, so we've only got 2 minutes.
No, I figured it was.
We're not going to get through the whole thing. Here's what I care about. Can we figure out the thing that's always true? You need some sort of a relationship that connects all the things. We know the lamppost is 15 feet tall. We know the guy is 6 feet tall. Palamon, can you make the guy walk?
No, he's 6 foot tall. I don't think I can make him do anything.
I'm sure you can do this. Okay? So like that's what's happening. There's the guy, there's the lamppost, there's the tip of the shadow. What happens is he walks away from the lamppost in terms of his shadow. It's getting longer, right? There's all sorts of like good like physics reasons and trig reasons why that has to be true. Palamon, let's get him to stop walking.
He's a stick.
Well, he is. He's skinny. The relationship that's always true here. How many guys see something that's always true?
His height?
He's always 6 feet tall. He is not shrinking. Some relationship that's going to pull things together. Aaron, what do you see?
Some Pythagorean theorem stuff.
Definitely some Pythagorean theorem stuff. The other thing, there's 2 triangles here.
Oh, there is.
There's 2 triangles. David, where are the 2 triangles?
It's going to be the shadow one,
Yeah.
and then from the answer all the way to one.
There's that one, and then there's this one. And that is going to be really important because you've got this blue triangle inside the black triangle, right? It's an embedded triangle. That means that the blue triangle and the black triangle are going to be proportional. You know that his height is 6. You know the height of the lamppost is 15. How long is his shadow? I actually don't know how long his shadow is. How far away is he from the lamppost? Well, at some moment in time, he is 10. But how far away is he from the lamppost? It is going to change. If x is his horizontal distance, stay with me just for a second, the relationship that's always going to be true if I'm thinking proportionally, I can say that if I compare 6 to s, the height to his shadow, that's going to be equal to something else.
15 over x.
Not 15 over s.
It's gonna be
Height,
over x,
shadow,
x plus x.
height,
X plus s.
x plus s. 15 over x plus s. And they want to know how fast is the tip of his shadow moving? Right? How ds dt. Do we know dx dt?
Yeah.
dx dt should represent how fast he's walking. Positive or negative? Positive because he's walking away from the point. Right? If this relationship's always true, this is the thing you can take the derivative of, which would mean quotient rule and quotient rule. Or because this is always true, how about cross multiply and say 6 times x plus s equals 15s? And you could even work that out a little bit more if you wanted to. And you're going to get that 6x equals 9s. Really easy to take a derivative of, really easy to finish off from here. Alright, see you guys later.
Anyone would like